Hey everyone, and welcome to our YouTube channel. In this video, we are going to talk about some of the very important functions of Pandas. So as you know, Pandas is basically a library in Python, which help you deal with a lot of data related, computations. So it gives you a very famous data structure, right? Called as data frame, along with definitely series object. And you can do almost any kind of work for data preparation, creating machine learning models, data analysis, and whatsoever, right? So it's a very powerful tool which you can use. And the great thing is it's simple as well. So what I have done over here is, I have collected few very important functions that you should be aware of, right, to get started with Pandas. Some of them are very basic functions. Some of those are quite advanced functions. So you'll enjoy, going through this particular video. I would suggest you guys to try it along with me for, for a kind of hands-on experiences. So let's start with it. The data set that I'm going to use for this particular video is emptycars.csv. This is a car related data set. And within a few seconds, I'll be showing you what all things I have in this data set. So I have already uploaded it. I'm using Google Colab for Jupyter Notebook. It doesn't matter what platform you are using it. So let's start. So to import Pandas library, I'll use import Pandas as PD. Maybe, I'll also import NumPy. I'll create a separate video on NumPy sometime later for any numerical related computation. And now I need to get the file right. So let me take the data name as df. Here I am using df to store the emptycars.csv dataset. To import a CSV file, we have a function called as read_CSV. So we need to put PD, which is for pandas, read_CSV. And here I need to provide file path along with file name. So I'll just copy the path here, paste it over there, and that's it. Okay, that's been loaded. Now let me close this window and let's check some of the data set. To look at the top record, right? And maybe what I can do is, I can write the comments also. Check top records. So for that, we have a function name called as head. So df.head, and this would give me some top record from your data set. So by default, it gives you top 5 records. So you can see index number 0, 1, 2, 3, and 4, right? And all the columns in your data set. So first column is serial number, second column is unnamed one, right? We can rename it a little later. Then we have MPG, cylinder, displacement, HP, and a lot more, right? So this is how my data set looks like. So head function basically gives you top record from your data set. If you want to customize, let's say in place of top 5, I want top 10. So I can just put 10 here, and this will give me top 10. If I want top 2 only, so just put argument as 2, and you are done. Similarly, if you want to look for bottom 5 by default or bottom 2, bottom 3, we have a function called as tail, right? So if I do df.tail by default, it will give you bottom 5 records. If you'll do bottom 3, df.tail provide argument as 3. Right. So this is how basically, loading a file works. Cool. If you want to look for all the columns, right? And we are going a little fast because these are like very simple functions. If you want to look for all the columns in your data set, we have something called as columns. Remember, columns is not a function, right? So we won't be providing it in parentheses. So df as my data set name and columns. So this will give you all the columns in your data set. So as you can see, we have serial number, we have unnamed one, MPG, cylinder, and whatsoever, right? So this basically help you to get the details, all the column names. If you want to look the information about your data set, info is the function name. This will give you all the information about your data set. So this says me, it's a Pandas data frame with 32 total entries, indexing 0 to 31, total 13 columns. These are the column names, how many not null records are there. And the third column is data type, right? For example, serial number is an integer data type, unnamed one is an object data type, MPG is a floating point data type, and so on. You can see one of the column called as QSEC is basically having 3 null record, right? We will look into it little later. Cool. If you have to drop a particular column, right, you can drop that with the, with the function called as drop. So drop function basically help you to drop a particular column. For example, let's say I want to drop a column called as AM, right? So let's drop that. So drop a column, right? So df, you store it, df dot drop. Drop is the function name. And here I need to provide columns equal to what all column you want to drop, right? So let's say I want to drop a column called as AM. Very simple, right? And that's it. Just execute it, done. And now if I'll check df dot head, I should not see the AM column unless we are doing some mistakes. As you can see, we no longer have AM column, right? So drop function basically gives you the feasibility to drop one or more column. If you want to drop more column, all you need to do is provide this as a list. So AM, then let's say I also want to drop carb, so you can provide like this, right? I'm not doing it, so I'll just remove it for now. But you can drop as many as you want. Next in my list is length. Length provides you the length of your data frame. For example, len is the function name, right? df. This should give you the total length of your data set. In my case, it's 32. So basically, this is nothing but the number of records in your data set. Cool. We have another function called as query. Query function. What it does, using query function, you can filter or query using some Boolean expression, right? Like for example, let's say I'm doing df dot query, right? And here I'm checking, give me the records where let's say where gear is greater than carb, right? So what I'll do is I'll put gear here, gear is greater than carb, right? So this should be your query. And now let's look at it. So you can see we have now all the records where gear is greater than carb, right? So 4, 3, you can see here, right? So this is a very good feature which help you to do any query in your data set. Then, if you want to access a particular column, you can do multiple ways. For example, df is my data set name. I want to access a column called as, let's say, WT, right? So I can do like this, right? This is one way to do it. And even all the function will work. Like for example, I'm looking for some top records of WT column. This is how you can do it. You can also do that using a function called as iloc. How? Simple. df.iloc, right? ILOC. And here you have to provide what you need, right? So default feature is, put a comma. Before comma, it's row index. After comma, it's column index. WT is a column, and you have to count the index of it. So this is your first, second, third, fourth, fifth, sixth, seventh, and eighth, right? So 8 is the index number. So let me put 8 over here, right? And here I don't, I'm looking for all the records. I'll just put this one. Let's see, right? So this should give you, let's look at it. This is 1, 2, 3, 4, 5, 6, 7, 8, right? So you have to provide basically the index, index number of that particular column, right? So let's quickly count it. Let's quickly count it. Like this is 0th index, first index, second, third, fourth, fifth, sixth, seventh. So WT is the 7th index. So you have to provide it here, 7. Let's look at it. Yeah. So you can see here this value and these value are same, right? So this basically gives you WT. You can also look at the column names using location also. This is basically I location, right? So basically I location means index of the location. You can also get using the column names as well, right? Like df.log, that's for exact location. And here you can provide, let's say I am looking for column, a row index is like 2, 3, let's say 5, right? And let's say I'm looking for columns like WT, I'm looking for columns like carb, right? And whatsoever. So basically, these are some of the great ways to get you the columns and records. First, just use the column name the way we have the way we have done here, right? You can use index location also, or you can use simple location as well, right? So these are the different ways using which you can get the column details, row details, you can index it, etc. Cool. The next in our list is something called as D types. For example, let's say in this data set, which is df, let's call it as again. info, right? You can see bunch of data types are there. Integer is there, objects is there, floating point is there. Now let's say I want to get all the records, all the columns of my data set having data type as int64. You can do that as well. How? df is my data set name, select underscore d types. This will select the d types that you are looking for. Includes equal to, let's say I'm looking for only int64. And here you go. This will give you, oops, some problem, right? It's not includes, it's include, right? So this will give you all the records, all the columns from your data set, which are integer 64. So you can see here, right? Car, gear, what else? HP, CYL, serial number. So these are interrelated columns. So we are getting those details over here, right? So select underscore d type basically help you to filter your data set for that particular data types. The good thing is we can also use exclude also. Like for example, I want all the data types, right? I want all the data types except integer. So for that, we can use something called as exclude here. So exclude. So this should give you the data frame, right? Without integer data types. You can see unnamed one, MPG, displacement. So these are either object or floating point numbers, right? So select underscore d type help you to filter based upon the data type available in your data. If you want to have the cumulative sum, you can do that as well. How? Let's say df dot, right, or probably df, let's say I want to have a cumulative sum for wt column. So I can do the function called as cumsum, right? So cumsum basically does the cumulative total for you, right? You can do for multiple columns as well. Let's say I want to do for wt as well as I want to also do for, let's say, carb. So here I can do carb also. So this will give you cumulative sum for both the columns, right? Separately, of course. If you want to look for some sample record from a data set, two ways are there. First, df.sample, and here you can put how many sample record you are looking for. Let's say I'm looking for 10 sample records. So this will give you 10 random records from a data set. This is one way to do it. Another way is provide the percentage, right? Instead of any real number, I want like 20% as the sample. So what I can do, df.sample, same function. Here in place of n, provide frac. Frac equal to 0.2 means I am looking for 20% of my data set, right? So this will give you 20% sample record from your data set. Our data set is having 32 records, so 20% of it should be around 6, right? 1, 2, 3, 4, 5, 6. So 6 records I have received. Cool. There is a function called as where. The where function basically help you to meet certain criteria and you will get the result. Like for example, df, let's say I'm putting column like MPG, and I'm looking for those column of or those records where MPG is greater than, let's say, 30. So what I'll do, where df MPG, right? df MPG is greater than 30. So if it will have any record, it will give me, else null value will be there. So see, most of the records having MPG column as less than 30, there are only 1, 2, 3, 4 records having value greater than 30, and so you are getting that as an output. So where column basically help you to filter a particular data set for a particular expression. The good thing about where is currently we are getting all NaN, right? Wherever the condition is not met. If you want to put it as 0, so put 0 here, and this should give you 0 value where the condition is not met and the actual value where the condition is met. So that's basically where conditions. If you want to get for unique record in your data set, we have the function called as, let's say, we want to get the unique record in WT column. So df.wt, unique is the function name. So this should give you the unique record, right? So in WT column, we have these many unique records. Let's take little better one. Let's say gear, right? So if I do gear, so we are saying like, okay, gear column has only 3 unique records. Those are 3, 4, and 5. And if you want to count how many unique records we have, just use any unique. Unique will give you the unique records, and unique will give you the number of unique records. So you can see we have only 3 unique records in my data set. in my data set in gear column. If you want to look for number of unique records in all the columns, very simple. Do data set name and then unique. df.n unique, and this will give you by column. So in serial number, you have 32 unique records, in unnamed one 32, in carv 6 only, in vs2 only, and so on. Right? We have a function called as replace. That function replaces all the values that matches. Like for example, df.replace. Let's say I want to change all the values in my data set, which is 1 to, let's say, 100. Right? So what I can do? Simple. I will change 1 to 100. And let's say if it's working or not. Look at it. All the ones have been now changed to 100. Right? So replace function basically help you to change something. If you want to change the column name, right? Initially, I told you that we have a column called unnamed one. So if you want to change that, you can use rename function. How? df.rename. Here you can provide columns, right? Columns equal to, and here old column followed by new column name, I mean, right? So for example, my old column name is this one. Make sure that you are providing it correctly, else it won't work. So here, and then let's say I'm making change like car model, and that's it. So you can see the column name has been changed to car model now, right? So dot rename function basically help you with this. As I said earlier, right, we have certain records in the QSEC column having null values. If you want to replace that null value with, let's say, 0, so you can do that as well. df QSEC, right, column. We have a function called as fill_na, right? Here you can put, I want to do it for 0, and then in place equal to true, so that it will make changes in your original data set, right? So this way you can, you can make the changes. Now, if I'll look for df.info, I should not see any kind of null record in your data set, right? See here, all 32, right? So these are some of the important functions, basic functions to be precise, right? In Pandas, we'll take another one with some of the advanced functions in some later video. Thank you.